Hello, this is my pre-individual space lesson for inequalities in one triangle. And essentially, we're trying to study relationships within triangles that we know exist that would help us determine lengths, determine feasibility of a triangle, and things of that nature. So our objective today is to use inequalities involving angles and sides of triangles. So questions we're looking to answer today are what characteristics that a triangle must meet, and how do the sides and angles of a triangle relate to one another. So one of the corollaries that we have to the exterior angle theorem, which is something we studied back in Unit 4, I believe, we learned that an exterior angle's measurement equals the sum of the two remote interior angles. And since it's the combination of two measurements, it almost stands to reason that the measure of that exterior angle is going to be greater than the measurement of any single one of those angles, since it's made up of the sum of both of them. So that one's kind of straightforward, although there's a formal proof for it. So basically, that exterior angle is going to be greater than the measurement of angle 2 as well as the greater measurement of angle 3 individually. So in this question here, and how you could determine some things here, explain why the measurement of angle 1 is greater than the measurement of angle 4. Now, I don't have any measurements, so I have to use, theorems and rules and properties and what have you. I can see that, I could probably just use that theorem I just used, but I show here that the measurement of angle 1 is the measurement of angle 2 and the measurement of angle 3 combined. And since it's, kind of like an informal proof of the previous theorem we just looked at, since angle 3 is congruent to angle 4, it means their measurements are the same. So note the measurement of angle 1 is basically equal to the measurement of angle 2 and the measurement of angle 4 added together. Well, that stands to reason that since it's the sum of those two angles, if I just look at the comparison of the angle 1 and angle 4, the measurement of angle 1 has to be greater than the measurement of angle 4. So, now another theorem that we look at, another characteristic of triangles that we study, is essentially this one here. And essentially, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So basically, if I look at two sides of a triangle, and I compare them, then I know the angles opposite of them, how their measurements would relate to each other. I'm not necessarily going to know what their actual measurements are unless I'm told that here's the measurements of these angles, here's where the sides go, which angles go to which measurements. I can match them up that way, but I can tell which ones are going to be greater based off of what they're opposite of. So for instance, which corner of the triangular plot of land forms the largest angle? So a lot of students will mistakenly use the figure itself and kind of judge, and they'll say, okay, well, I know that it looks like, this side looks longer, but I actually have measurements there. Now, we're not told what the units are, but I see that AB is 47, AC is 62, and BC is 55. AC is clearly the longest side of this triangle, and by that rule we just looked at, it means that angle B, the angle opposite of it, must be the largest angle. And it works the same way as far as, smallest side versus smallest angles and whatnot. The reverse of that is also true. If I look at if I know what the angle measurements are, I can see which angle is bigger than the next, then I can determine which side is going to be bigger than the other because of what sides are opposite of them. So here, angle A is greater than the measurement of angle B. That means that the side opposite angle A, or BC, is going to be greater than the measurement of the segment AB or AC, because that's the angle that's opposite is smaller than angle A. So I look at a situation like this. Which choice shows that the sides of triangle LMN is in order from shortest to longest? So since I'm going to be looking to determine, basically what the smallest side is first, well, the smallest side of this triangle should be opposite the smallest angle. And when I look at the three angles in that triangle, angle N is the shortest. So this side I'm marking right here is the shortest side. So any option that has LM being first is still an option. So that means that for my purposes here, choice B and choice D are out. So now I look to see, okay, you know, which one has the longest side? Well, the longest side would be opposite the biggest angle, and the 65-degree angle is the biggest angle. So I'm looking for LN to be in the last position, and that's what this one is here. So that's why, you know, of the choices I have, C is the choice that goes from shortest to longest.